Welcome to today's tutorial. Before we start our today lesson, kindly subscribe down there so that every time we post a new materials you will be the first one to get the notification. Now today we want to look at solution to differential equations, and we would like to do this with some definitions here. So if you have a function of that of u of xy, we call this a solution to a dE, and that particular dE is this one here. If it satisfies a dE, it satisfies this dE. Satisfying this is that if you substitute, you get the answer that the dE is given to have. Thus, if as we substitute it, we substitute this particular solution into that dE, we automatically get 0. So in this case here, we expect the answer to be 0. So a general solution to one dE is the one with constants. So if you get a solution with constants, maybe after integration, that we call that particular solution to ODE a general solution. Then a particular solution is the one which arbitrarily constants have been specified. So here we have the values for the constants. That particular solution is particular. If you have constants, that particular solution is general solution. If we discuss this geometrically, we mean general solution is a family of curves. It's a family of curves associated to that given differential equation, while particular solution is one specified curve. So if you want to graphically represent a particular solution, you'll find one specified curve. If you geometrically or graphically want to represent a general solution, you get a family of curves. So that's the difference. So we can get a particular solution from general solution by using some given initial conditions. So if you are given initial conditions, then you'll get a particular solution. These initial conditions, which have been specified to some values of a given value x, are what we call initial values, and they give us what we call initial value problem, IVP, initial value problems. That is only some value, a particular value of x. But if you have more than one value of independent variable, in this case as initial conditions, we come up with what we call boundary value problem. So that problem becomes boundary value problem. It's like you have given x to be within 1 and 3. So you can see in this case here, the solutions for initial condition for x are 2. x1 is 1, and these are boundary value problems. For initial value problem, you'll find that the value of x is actually given like just 1. So it's 1. So that's the initial value problem. In case you have a question on either of these parts, kindly leave a comment. I'll be able to check on it and respond to you immediately. Okay, let's look at an example. So we are given this example here. Show that this particular solution with constants, of course, is a general solution. If it's such constant, then they are not specified, then we know this is a general solution to an dE. Which dE? This particular dE, and particular dE. So then to find a particular solution given the initial conditions. So this is now a initial value problem, because the values here given are only 1. So if we talk about y, in 0 given, then 9, it means this case our x is equal to 0 and y is equal to 6. Okay, now check out this. First thing that we need to do here is to work out for the derivatives. So the first case, we know this is the general solution. Secondly, you differentiate this first derivative, and thirdly you get the second derivative. Why are you getting the second derivative? Why are you getting second derivative? Because in our general DE, it starts with the second derivative, first derivative, and this is y, which is the function which is not derivative. So we just need to differentiate in those areas. Okay, next. Now substitute the DE, substitute those values of first derivative, second derivative, and the function of y into the DE, the differential equation. So differentiate them here. So the first and the second derivative is actually this one. So substitute there. This negative is actually this negative here. So the y first derivative is actually this, and 2y, this is our y with our general equation. So when you solve this one, you are again going to get 0, which is this one here, is required. And that means what? It means that the general equation y equal to c1 exponential minus 1, that one, the one given, it is actually the solution, general solution for, so this one is the general solution for this. And by doing those, you have shown that that particular general solution is actually a solution to that given DE. So that's basically what you need to do. Now let's see how we get a particular solution. Now let us work for particular solution. Remember, we have been given initial conditions, and the initial condition is that one is there and the other one is here. So if you are, this implies that whichever is in the parentheses is the value of x. So in this, the two cases here, when the derivative one, x is 0, and in the general value, x is 0. So therefore, substituting respectively the values of x and y. So y in the first case is 9 and x is 0. So that's the reason you can see zeros there, e to power 0. Then the next one, the solution is 6, and the powers here is 0, 2x, 2 into bracket 2 to bracket x. So you see 2 times 0 is 0. So the reason I'm powering with 0 is exponential 0. So what we have here, these two are actually simultaneous equations, and we solve them using simultaneous equation methods. Again, in the previous tutorial, I looked at how we solve simultaneous equations using different methods. So look at that video up there and pass through it, and you'll be able to see how we can solve this. And you'll be able to remember that. In case you have any question about this, also remember to leave a comment down there. Okay, now if you solve this, you'll find that C1 is 4 and the C2 is 5. C2 is 5. So this means that our particular solution for our DE now, substituting the value of C1 and the value of C2, is actually this. And this is now what we are calling particular solution for this differential equation. So we have looked two things: general solutions, they have seen types constants, and they have looked at particular. The C's have been substituted. That's what we call particular solution for this given DE. it is given DE. So after that, we can close out today's class, and make sure you subscribe. Make sure you subscribe so that every time I post any video or any tutorial to this, you will be the first one to get this. So for now, I say bye until next.